in statistics to measure or to make conclusions on some analysis. So what is hypothesis? What is an hypothesis? What is hypothesis? What do we mean by hypothesis? Yes? Or what do you understand by the name hypothesis? First of all, today we are on day 8. So
is a proposed statement that is based on a
yeah, very true. And else nani mwingine ako na maoni? Nani huyo mwenye ameongea? Joy, what is an hypothesis? Joy, what is an hypothesis? Okay, let's have a look on what I prepared here for this lesson. So hypothesis testing is just an act in statistics whereby an analyst will test an assumption regarding a population parameter. So yeah, just that simple definition tells what an hypothesis testing is. So the methodology employed by the analyst depends on the nature of data used and the reasons for the analysis. What we mean by that, the nature of data, for example, we have so many assumptions associated with some specific statistical methods used in analysis. So you remember, for example, when you are carrying out regression analysis, we assume that your data is normally distributed. What if your data is not normally distributed? You shift from a regression analysis, which is a parametric method, to non-parametric method. So that's what we mean by the methodology. That's what we mean by the nature of data used and the reason for the analysis. So hypothesis testing is used to assess the plausibility of an hypothesis by using the sample data. So such data may come from large populations or from a data generating process. So the large population will be used for these cases in the following descriptions. Now, how hypothesis testing works? That is a question that you need to have in your mind before we start on application of methods used to analyze hypothesis. So in hypothesis testing, an analyst will test a statistical sample with the goal of providing evidence on the plausibility of the null hypothesis. So statistical analysts test the hypothesis by measuring and examining a random sample of the population being analyzed. So all analysts use a random population sample to test the two different hypotheses the null and the alternative. The null and the alternative. So what is a null hypothesis? You need to understand now what do we mean by null hypothesis and the alternative. So null hypothesis is usually an hypothesis of equality between population parameters. For example, null hypothesis may state that the population mean return is equal to 0. That's the null. So we are using sample data to test the claim that the population mean is equal to 0. So if our data does not support that claim, or if our data supports that claim, we make conclusions based on the alternative of the null hypothesis. So the alternative hypothesis is the opposite of the null hypothesis. For example, according to the first null hypothesis that we had up there, so the alternative hypothesis would be the population mean return is not equal to 0. So if your sample data does not support your claim, then you make the conclusions based on the opposite of the null hypothesis, which is in this case the alternative hypothesis. The alternative hypothesis. Thus, there are multiple sioni vizuri. Let's go to the second presentation here. Now, what are the steps for testing the hypothesis? Steps of hypothesis testing. All hypotheses are tested using 4 steps. The first step is that the analyst will state the 2 hypotheses, that is null and alternative, so that only one can be right and the other can be wrong. So the next the second step is to formulate the analysis plan, which outlines how the data will be evaluated. Which outlines how your data will be evaluated. So the third step is to carry out the plan and physically analyze the sample data So the fourth and final step is to analyze the results and either reject the null hypothesis or state that the null hypothesis is plausible given the data. So we will look on 4 things, but we did some things here on parametric methods. You remember that when we were doing a regression analysis? You remember that? Yes. So we will cover on the process of formulating what? Formulating hypothesis. The second one, we will look on one sample hypothesis test and the independence test. And the independence test. Yeah, so these are things that we will look into. And for the first one, I think I didn't document this one here. Let me see. What is happening here? Okay, I will just mention the process of formulating hypothesis. I did document these on this document. Then from there, we will do these other two practically using the software, because these are just theories for formulating the theories. They are the ones that are used in formulating what? In formulating the hypothesis. And formulating hypothesis is an important step in statistical analysis process, and a hypothesis is proposed explanation or statement that can be tested and potentially supported or rejected based on the evidence. So yes, just a general process of formulating an hypothesis in data analysis. The first one is always to identify the research question, where you clearly define the question or problem that you want to investigate. So it should be specific and focused to the point. And the second part is review existing knowledge. Yeah, you just review the existing knowledge or conduct a literature review to gather information about previous studies that were recorded earlier, theories or empirical evidences that are related to the research question that you want. So this step basically helps to understand what is already known and provides a basis for formulating your own hypothesis. So yeah. The third part is always specifying the null and the alternative hypothesis. You remember the H0 and H1 or HA, whatever you want to present it. So yeah. So the fourth step in determining the type of hypothesis. Remember, actually in statistics we have types of hypothesis, and depending on your research question, you may formulate one or three types of hypothesis. We have directional hypothesis, non-directional hypothesis, and the null hypothesis. But most of the time we always use the null hypothesis. So by default we always use the null hypothesis. But what is a directional hypothesis, if I may ask? Okay, if I give you information about a certain study and tell you I think the mean is greater than the proposed one or is less than, so that's what we mean by directional hypothesis. Or one tail, either it's greater than or less than. So it specifies the direction of the expected effect, expected effect. See there? Yeah. So for example, the average score of group A will be higher than the average score of group B. So that is one-tailed hypothesis, and that's what we call a directional hypothesis. We have non-directional. Non-directional is the opposite of directional. That is it two-tailed here? Yeah, two-tailed. And for example, there will be a difference in average score between, let's say, group A and group B. So I don't know the specific difference, but I know there will be difference. So I don't know which is as bigger than the other. So that what we call non-directional hypothesis. The other one is the null hypothesis, and it states that there is no significant difference or relationship between variables. So there is no difference in average score. Yeah, yes. So the fifth step in formulating the hypothesis is to define a variable and the operational definitions. This is where you clearly define the variables involved in your hypothesis and specify how you will measure or manipulate them. And this step basically helps ensure clarity and consistency in your hypothesis. And the sixth step is always to consider the testable implications. You determine the testable implications or predictions that arise from the hypothesis. From there, you can analyze your data and draw conclusions and then interpret your results. So based on your analysis, you interpret the findings and evaluate whether they provide evidence to support or reject your hypothesis. So just consider the limitations of the study and potential alternative explanations for the results. So those are just some theories that you have to use when formulating your hypothesis. So yeah. From that, now we do one sample hypothesis test. One sample hypothesis test, and I have an example here. An example question in question form, where you will have to use a t-test on one sample. So you will have to use t-test on one sample. This is the question. A lecturer wants to determine how students test anxiety. So it's affected by the use of hypnotherapy program. So as such, the lecturer plans to carry out a study where 40 students are split randomly into two groups. One group of 20 students who receives the hypnotherapy program, and the second group of 20 students who do not receive the hypnotherapy. How do we spell these ones? Hypnotherapy program. Yeah. So then, before all 40 students sit an exam, the lecturer measures their test anxiety. So to measure the difference in test anxiety between the two groups of students, so the lecturer could use an independent t-test. So yes. However, before the lecturer carries out this study, he wants to make sure that the 40 students taking part of test anxiety level that are considered to be normal. Yeah, you come up with a normal measure that you want to test your data based on it. So let's imagine that a score of 8.0 is considered to reflect normal test anxiety level. So lower scores indicate less anxiety and higher scores indicate greater test anxiety. So therefore, The test anxiety of all 40 participants is mentioned, and a one sample t-test is used to determine whether these samples is representative of a normal population, whether the participant mean test anxiety score is statistically significant, different from 8. Remember, 8 is considered to be normal for this matter. So the text anxiety scores are recorded in variable that is called the text anxiety. I want as we input some data, random data in STATA, and we can demonstrate what we mean by this part. So I want everyone to open his or a program. So starting by clearing any data that is present in your STATA memory. Click on this part here, data head data, then insert values randomly. So ukitaka kuinsert all the 40 values you can, but just for demonstration, interpretation is what matters, because the one that is documented there will not be the one used for daily things. I think you understand. So the concept of interpreting the output is more important. So yes, suppose we want to insert those values, so you can insert just random values. Sawa. Just insert random values. Just insert 40 random values. Insert 40 random values in your, yes, those are 40. Are we together? Nataka kusikia sauti yenu ili nione kama hakuna mwenye amepotea. Are we together? Yes?
Yes.
So you just insert 40 random values in your machine.
Let me ask. Can I insert random values, but 1 up to 40 continuously?
Yes, but now it will not make sense, because imagine we want to test against random mean of 8. So you can insert values from, yes, it makes sense. By the way, you can insert values from 1 to 40 if you want.
Okay.
Yeah. So we want to change the name. We want to change the name to test anxiety. Sawa. Test anxiety. So click on this part under properties and type test anxiety. Yes, click on enter. So that is the values that I have there. Are we together up to that point? Nataka kusikia kila mtu amefanya hivyo. Nani amebaki? Are we together? Priscilla? Priscilla?
Yes. Yes, we're together.
We are together. Frinda,
Yes.
we are together, Sindo.
Yeah.
Yeah. So I hope you have inserted those values there. Mhm. And you will notice that after inserting all those values, commands for inserting those values zinajitokeza tu hapa, si ndio? Yeah, zinajitoa tu hapa automatically. So let's continue now. Everything is okay up to that point. We are going to run one sample t-test using both commands, then GUI, that is the graphical user interface. So yes. So in this section, we show you how to analyze your data using one sample t-test in statistics in STATA when the four assumptions. Remember there are some assumptions that are associated with specific tests, as we said in our introduction, in our introductory part. And what are the assumptions? What are these assumptions, by the way, if I may ask? Yes? What are those assumptions? Nataka kusikia kutoka kwenyu. Yes? Hey watu. What are assumptions associated with the t-test? What are they? Okay, I can tell you. The first assumption is the independence. We assume that each point or each score from students, they are independent of each other. So the observations within each group, even if we were testing more than one group, so these observations must be independent of each other. So in the case of an independent sample t-test, independence means that the individuals in one group are unrelated to the other. So for a parent sample t-test, the other assumption is the normality test. You remember the test that the methods that are used to test for normality, and one is the Shapiro. Those things, I'm sure you remember them. The other assumption for t-test is the homogeneity of variances, and the variances within each the variance within each group for variances or just variances of the differences in apparent sample are approximately equal. They are approximately equal. So the fourth one is the interval or racial scale, and the data being analyzed admission on either an interval or ratio scale. So I assume that the data is in interval or ratio scale. So now these scales they provide meaningful and consistent measurement that allow meaningful comparison and calculation. So those are the types of assumptions that we are talking of here. Now we assume that these assumptions have been met, and now we can compute the analysis. The first one, I want you copy this code here, t-test dependent variable double equal sign to the hypothesized variable value, control C, not control C, copy the way you want and paste it here on the command line. Just a minute. Just a minute. I want you copy this one here. Yes, I want to copy this one here for the t-test. T-test test anxiety is equals 8 or 8.0. What are you getting here? Okay, this is the output of the t-test. This is just an output of the t-test. So it means we have 40 observations. This is the mean of the text anxiety. We have the standard error for estimates. We have standard deviation and 95% confidence intervals here. Mean is this mean here. We have the t or the test statistics. This is the test statistics that we have is negative 4.0167. We have the h naught. H naught is the null hypothesis. We want to tell that the mean for test anxiety is indeed 8.0. Are we together? These are the degrees of freedom. For less, the p-value I want to be very keen here. The p-value associated with the mean that is less than 0. That is less than our mean of 8. The p-value is 0.001. So ukiona hiyo unajua we have some conclusions based on this mean. So it means that the actual mean of test anxiety is less than 8. Na tukiangalia hapa unaona it's actually less than 8. We can conclude either not equal. You remember this, the use of this sign here. The mean is not equal to 8. The mean is not equal to 8. Yes. The p value associated with this test here is less than 0.05, sindio? So we can also conclude based on this part here. We can say the mean is not equal to 8. So the mean is not equal to 8. We can do conclusion based on this one here. The mean is greater than 8, and the p-value associated with it is 0.9. It is greater than alpha. Is greater than alpha. So in Iwango, this is false. This is false. So statistically, based on this p-value, we reject this null hypothesis. Are we together? We reject the null hypothesis that the mean is not greater. The mean indeed is not greater than 8. Based on this part, the HA. Sawa. Okay. Nani hajaelewa venye tuna interpret this output? Nani hajaelewa venye tuna interpret that output?
Kindly repeat.
Okay, let me repeat. We have the anxiety values here. Sawa. These are the anxiety values. Are we together at that point? We want to test the mean of text anxiety compared to the actual mean of 8. So to the actual mean of 8. So basically what we want to say, we want to tell whether the mean of text anxiety is equal to 8. Is equal to 8. Sawa. And we have the observations here. We have the test values here. This is the mean for test anxiety. Sawa. This is the actual mean. Yenye iko kwa uwanja sasa. It is 6.875. Sawa.
Okay.
That is the mean.
Yes.
We have the T. This is the test statistics, but hii hatuitumiangi sana because in computations we only use the p-value, sindio? Tunatumianga p-value either to reject or fail to reject the null hypothesis. Sawa. Yes. So the H naught is the null hypothesis. My null hypothesis is that the mean of text anxiety is equal to 8. So that is my assumption.
Yes.
I assume that mean for text anxiety is equal to 8. But now my computer tells me otherwise. If we have the alternative, this is the null hypothesis, this is the alternative hypothesis. So if we have remember what we are testing. Okay, between null hypothesis and alternative hypothesis, which one is tested? Is it the null or the alternative? I want to hear from you.
The null.
The null hypothesis. Null hypothesis is used to conclude. What about the HA? HA is the alternative. Remember, ndio maana tuliweka our test anxiety to be equal to 8. So that is our null hypothesis. That is our null hypothesis. So we want to tell that the mean of test anxiety is indeed equal to 8. But now STATA gives you you 3 options. STATA will give you 3 options here. Itakupea yenye iko less than 8. Itakupea yenye iko not equal to 8. Itakupea yenye iko greater than 8. Sawa sawa. So to conclude this part only, we would use the second part here. Sindio? Is it making sense? What is the opposite of mean being equal to 8?
It is not equal to.
Not equal to 8. Sindio? Now this is the not equal. This is the not equal. This one here. So tungeachana na hizi kidogo, then we make conclusions based on this one. Sindio?
Okay.
Yeah. And for this one, the probability or the p-value is 0.0003. P-value is less than alpha of 0.5. So we make conclusions based on that part. Now I want us we do the same but using the GUI, and I'm sure we will get the same output. So we are using the GUI, that is the graphical user interface. Let's see. You just click on statistics and summarize, then you go to the classical and t-test. Sawa sawa. Just click on statistics and summary tables and tests, then go to classical test of hypothesis, then click on t-test, mean comparison test. So mean comparison test. Click on that, and we have so many options here. We have one sample, we have two samples using groups, we have two groups using variables, we have pairs. So I want us we use the one sample. So and on variable name,
yes,
you
test
anxiety. And what is the hypothesized mean? What is the hypothesized mean?
8.
I want to test against 8. From there, we have even the confidence level here. We have the confidence level. You can vary the confidence level if you want, but by default, let's use the 95%. So from there, you can just click OK and get your output. Sawa. Mumepata hiyo maneno?
So just a question.
Yes.
Why are we not saying that why are we not using the first option where mean is less than 8?
Less than 8.
Yes.
What is our null hypothesis?
Mean is equals to 8.
Okay. Ebu soma that is our null hypothesis in sentence formula. The mean of test anxiety is
equal to 8.
Sindio, ina make sense, eh? So I can say the mean for test, I assume that the mean for test anxiety is equal to 8. Is it making sense? And what is the opposite of that sentence?
The mean of anxiety is not equal.
Is not equal. Sindio? hakuna story ya less than or greater than, si ndio? And ukikuja hapa kwa our output,
Okay.
we have less than na huku
Yes.
tuko na greater than, so this is actually the not equal, so we will use this one to make conclusions based on the null hypothesis that we have here. So
Yes.
yeah, that is it.
I have a question.
Yes.
So I'm curious if also for me my mean was 5 point something, so it's below. But then I wanted to know if somebody because we were using random numbers, if someone got mean that's above 8.
If
Somebody got a mean that is above 8, like in the class, if there's someone who got one that's above 8, because I think we've been operating on the assumption that everybody got a mean that is below 8, but we were putting in random numbers.
yeah, we were putting in random numbers, so what is your question based on that concept?
So my question is,
Yes.
if there is somebody here in the class
Yes.
who ended up with random numbers with a mean that would be above 8,
Okay.
and then in that case,
Uh-huh.
when we come to this,
Yes.
is their output, how is their output going to present differently from our output?
Okay. Number one, we will not have any student scoring a mean of greater than 8. Rather, we will have the actual score per student. So those values for test anxiety are actually per student. So are the content per student. And now the t-test, we are trying to tell whether what we think or what we assume is correct or wrong. Sijui kama unanipata.
Well, I think I'm understanding what she's saying
Uh-huh.
because my mean from my random numbers,
Yes.
I got a mean of 19.
Yeah.
So I think she's asking, what about if the mean is greater than 8?
Okay,
I
if the
think that
mean
is what she's asking.
if the mean is greater than 8,
Yes.
how will we conclude? Si ndio?
Yes, that's my question.
Okay. If the mean is greater than 8, how will you conclude? And remember, our t-test tulikuwa tunaiset our mean ikuwa equal to 8, but sasa imekuwa greater than 8, si ndio? So we will still use the second output to make a conclusion based on that one. So now the t-test will tell you whether your claim is valid or not, whether your claim is true or false. And for this matter, for example, my mean was less than 8. My mean was less than 8. So still, I would conclude that okay, what is your p-value? Before we continue, what is your p-value? Your p-value must be less than 0.05. Is it true? Nataka kusikia kutoka kwako.
Mine,
Yes.
it is 0.039.
0.039. So that p-value is still less than 0.05. Sindio?
Yes.
Then you will make your conclusion and say the mean the mean for text, anxiety is indeed not equal to 8. Sawa sawa, haitakuwa equal to 8. So we are not going to tell whether it is greater or less, but our claim ilikuwa to test it is equal to 8. So my p value suggests it is not equal to 8. So I don't want to know whether it is less or greater. Is your question answered? Is your question answered?
Yes, my question is answered.
Okay. I think we can now continue. Sindio?
Just a question.
Yes.
So what happens if the p-value is greater than 0.05, or I don't know.
Okay.
Yes.
Yes. What happens if the p-value is greater than 0.05? We fail to reject the null hypothesis. Sindio? We fail to
We reject.
No. We fail to reject. Ebu let
I
us.
don't understand.
Hebu tuende hapa kwa the final nini hapa kwa the, nataka tukuje hapa kwa, so this was a, hii ilikuwa sample ya, let's see. So this output provides useful descriptive statistics including the mean and 95% confidence interval, as well as the actual value from the one sample t-test. We can see that there is statistically significant difference. There is statistically significant difference between the test anxiety and the national population value of 8, because our p-value is greater than p-value is greater than the test statistics. So let's see, which is less than 0.05. Okay, in statistics, when do we reject or when do we fail to reject the null hypothesis? Yes, hizi ni vitu za campus. Mnanipata kweli ama nimepotea kwa mtandao?
Be true.
Are we together? Sijui kama mnanipata wallahi.
Tunakupata.
Ask your question again.
Mnanipata? Okay. Hii net yangu ilikuwa inasumbua kidogo. So let's continue. And how do we make conclusions on p-value? On the null hypothesis based on p-value? Yeah, that was my question. Yes.
We reject if the value is less than
We
the significant level.
So if the p-value is less than the significance level, what do?
We reject.
We reject, si ndio? And
Yes.
ukikuja kutumia the mathematical table plus the test statistics is the opposite, si ndio?
Yes.
Yeah, is the opposite. Hiyo yenye una reject if the test statistics is inakuwa greater something of kind, si ndio? Yeah. So for this one here, the p-value is less than 0.05, so we reject this one. So we reject this one and conclude that the mean is not equal to 8. So yeah, that is it. So hebu tuende kwa the independence test. Let's dive on the independence test, and here we use the chi-square test. So here we use the chi-square test, and the chi-square test of independence is used to determine whether or not there is significance association between two categorical variables. So for this example, we will use data sets, the auto data sets that is inbuilt in our STATA. Yes, and yes, mambo itakuwa sawa. So let's load the data first. So you clear memory ili kusikue na uchafu huko. Clear, type clear and click enter. So our memory is okay, and from that point we use auto. We are using the auto, so just copy this one, wiweke hapa auto, ama unaweza enda kuitafuta hapa kwa file, ukuja hapa kwa example dataset, then you come to this part here, kuna auto, this one here. I think this is it. Sawa. Yeah, so we are just using that one. I'm sure unafanya what I'm doing from my hand, and you can have a look on the data itself. So type browse, click enter. This is the data that we have here, and we can have a question on that we want to answer. You can have a question. So
I'm sorry, I didn't see which data we were getting.
we are using auto data, this one here. Click on files, example datasets, click on example datasets installed with this data and pick the first one, use. Click use auto, the first one. Sawa.
Okay.
Mko sawa mpaka hapo, si ndio?
Yes.
Yes, let's continue. How do we perform now a chi-square test of independence? We just do tabulation and acha turundi hapa kidogo. I want as we go through this part here. So for this example, we will use the dataset called auto. Yes, we have loaded the datasets, which contains information about 74 different automobiles from 1978. So use the following steps to perform a chi-square test of independence to determine, I want you to be very keen here, I want to determine if there is a significance association between the following two variables. I want to see, are they associated or not? We have the rep 78. These represent the number of times the car received a repair in 1978. These are repairs in 1978 in a range of 1 to 5. Foreign, whether or not the car type is foreign. So 0 is no, 1 is yes. So that is the kind of data that we have there. So we just do test, and first variable, let's see this one. I want to load that command and insert it here and perform this guy's variable first or not. Oh, that was not for this part, so we are using the second one, this one here. The exact syntax that you will use, oh, this is the syntax. The first one is the syntax. We table first variable, second variable, then chi-square. So we are going to table our first variable was rep 78 and our second variable was foreign. So that's why we are going to use this part here. So tab rep 78 K2. So just type tab, it is on 78, then foreign, where's the foreign is here, then comma, then ch2, chi-square. So just click enter. Unapata nini hapo? We are getting the repair and car type. And car type. So from this part we have the Pearson's chi-square of this part here, and the other one is the probability or the p-value. So we will make our conclusion whether the two variables are associated based on this value. So these are the interpretations. So the p-value that is associated with the chi-square test, it turns out to be 0. Since this is less than 0.05, we fail to reject the null hypothesis that the two variables are independent. So yes, we fail to reject that null hypothesis. So we have sufficient evidence to conclude that there is a statistical significance association between whether or not car was foreign and total number of repair it received. So that is a simple chi-square test of association. Any question? I didn't document these other things here because tulizifanya kwa class. You remember the non-parametrics, the Makruskawali's, the Smirnov test, Wilcoxon. Hizo utaenda kusoma hizo at your own time, yeah. So any question? Umekamata content? Priscilla?
Yes.
You are okay, Cinder?
Yes.
Frida?
I'm okay.
Okay, so kama hamna maswali, hiyo ndio ilikuwa content ya siku ya leo. Sawa.
I have a question.
Yes.
So you're going to be giving an assignment for this week.
Yes.
So I'm sorry, there's a class that I missed.
Mm-hmm.
So I wanted to know whether we were going to review the assignments from last week.
The assignment for last week.
Mm-hmm.
I suggest we review all of them at the end.
Okay.
Yeah.
That's fine.
Yeah.
Okay.
Just a concern.
Yes.
I was not able to submit my assignment for last week. Can I submit them both?
Unaonaje?